Okay, so we're going to look at free fall concepts and the required weekly homework problem related to free fall concepts. And this question says, you are throwing a ball straight up in the air. At the highest point, the balls, and then it gives you some options. A, velocity and acceleration are 0. B, velocity is non-zero, but acceleration is 0. C, acceleration is non-zero, but velocity is 0. And D, velocity and acceleration are both non-zero. So this is really looking at what does it mean to be in free fall and what happens at the highest point in an object's motion. So in free fall, we know that an object is always experiencing the influence of gravity. So part of our definition of free fall is that we have an object experiencing gravity. And that's an acceleration caused by the force of gravity, and we're going to get to that when we talk about forces. But the acceleration due to gravity has a constant value. It's constant depending on where you are on the Earth, but for the most part, we're going to use the value of negative 9.8 meters per second squared. So if an object is in free fall, it has an acceleration, period, has an acceleration of negative 9.8 meters per second squared. So why do we get tripped up at this peak idea? Well, we want to think about what's happening as the object goes through its motion and hits that peak. So the easy answer, at least part of it, is that yes, the acceleration is non-zero. And it's okay for you to remember that, just that if I'm in free fall, I always have an acceleration. We're going to use that in problem solving, of course. But it's also good to understand why. All right, let's imagine that that object is indeed moving in the upward direction. So here we have a ball that's moving upward. And what happens when a ball or an object, any object being thrown up, is moving upward? Well, our velocity at the beginning is non-zero. It's going to say greater than 0. It's greater than 0 meters per second. It's moving in the positive direction, and it's moving. So it has a positive non-zero value. Okay, well, this is sort of on the way up, keeping in mind. All right, so as it moves up, what does it do? Well, it slows down. Okay, which means the velocity is getting smaller and smaller and smaller. If the velocity is in the positive direction, and it's getting tinier and tinier and tinier, the acceleration has to be opposite the velocity. So on the way up, the acceleration has to be negative non-zero. It's slowing it down. Okay, positive velocity, slowing down, acceleration and velocity are opposite. We're making the number get smaller and smaller and smaller. I can only do that if I add a negative value. All right, well, let's just intercept that peak idea and look at it on the way down. What's happening on the way down? Well, at the very, very top, we know that the velocity is, as it's moving down, is going to be negative non-zero while it moves down. Okay, we're not looking at the top yet, just at negative non-zero. So we're somewhere in the middle of moving down. And it's getting faster and faster and faster. So it's speeding up. So that means that the object's value is getting bigger and bigger negative. So to do that, I have to add more negative. So I have to have an acceleration that is negative non-zero. Now, that's one way to think of it. The other is to remember that if I'm speeding up, my velocity and my acceleration are in the same direction. The acceleration is helping the velocity get bigger. And so if it's negative, then my acceleration has to be negative. So in both the ups and the downs, I have a negative non-zero. Okay, so I'm consistent with my free fall idea. What about at that very, very top? Well, at the very, very top, the object is going from moving up to moving down. It's changing its direction. And if it's changing its direction, it's going from a positive velocity to a negative velocity, in this case. And that means it's passing through 0. And it's at the top where it hits that passing through 0. So at the top, the velocity of the top is equal to 0 meters per second. It's passing through it. It's going from moving up to moving down. So it's got to be going through 0 velocity. And if we just kind of graph that for just a second, here's our velocity. That's in meters per second, of course, and our time is in seconds. I am moving from positive non-zero velocity, getting smaller and smaller and smaller. I'm slowing down until I hit a point where I have a negative velocity getting bigger and bigger and bigger. So that's my velocity versus time graph of an object moving, being tossed up. And right at this point, our velocity is equal to 0. That is at the top. All right, but we see that it's changing right before and changing right after, so the acceleration isn't 0 because it's changing. It's just passing through. And so we still have an acceleration, happens to be negative 9.8, the whole time, especially at that top. So the answer is going to be C, that the acceleration is non-zero. In fact, it's negative 9.8, but our velocity at the very top for that brief instant is 0.